Welcome to Shanti-Peace for Mathematics. In my previous videos, we have learned about what is partial derivatives and its geometrical interpretation. Also, we have discussed some examples related to it. In the one variable case, you have a function y is equal to f of x is given to you. If the function is differentiable, then it is guaranteed that the function has to be continuous. That means f is differentiable, then it will implies that f is continuous. That gives you a guarantee of continuity. But in the case of existence of partial derivative for multivariable functions does not guarantee the continuity of the function. That means a partial derivative of the functions are exist, it does not guarantee that the function is continuous. And if the function is continuous, it does not guarantee the partial derivatives are exist or not. So this video is specially based for that questions. So let us have some examples related to it, and then we will conclude what is the things we got at the end. So let's have the first example. The question is to find the partial derivative of function f with respect to x and y at the point 0, 0, where fxy is equal to xy into x square minus y square upon x square plus y square if xy is not equal to 0, 0, and 0 if xy is 0, 0. So the first of all, you should notice that here we have to calculate the partial derivative of the function with respect to x and y at 0, 0, and at 0, 0 this function have the values are deflect, that is for non-zero it has this value, at 0 will have this value. So as per the definition, what is the definition of the partial derivative? Let us recall fx at the point x0 y0, as you have studied in my previous one of the lecture, is nothing but the limit of f of x0 plus delta x y0 minus f of x0 y0 upon delta x as delta x tends to 0. That is the partial derivative of f with respect to x at point x0 y0. Here what is given to you is you have to calculate the partial derivative of f with respect to x at the point 0, 0. So here x0 y0 is the 0, 0 point. So this will turns out to be 0 plus delta x comma 0 minus f of 0, 0 upon delta x as delta x tends to 0. Now what is this? 0 plus delta x comma 0 is delta x comma 0. That means your x0 is non-zero. So that is this definition you have to apply, and f of 0, 0 will gives you 0. So according to that definition, if you apply, that is delta x tends to 0, in the denominator you will have delta x. Numerator, as per the definition, you can see that it is xy. So what is this? Is nothing but the f of delta x comma 0, this quantity will have. So instead of x we have delta x into 0 into delta x square minus 0 upon delta x square plus 0 minus f of 0, 0. As per this, it will become 0. So if you can say that delta x into 0, so this quantity will become 0. So you will have limit of delta x tends to 0, 0 upon delta x. So that will gives me 0. What will be the fx at point 0, 0? Same way, same definition, that is f of 0, 0 plus delta y minus f of 0, 0 upon delta y as delta y tends to 0. If I apply the function here, that is f of xy, as you know that f of xy function is given as xy into x square minus y square upon x square plus y square. This was the function given to you. So that is 0 and delta y is there. So that is limit of delta y tends to 0. In the denominator delta y is as it is. You have to substitute x, that is 0. So 0 delta y into 0 minus delta y square upon 0 plus delta y square minus 0. So the finally you will have 0 answer here also. So this way you can calculate the partial derivative at the given point. Let's have the next example. Consider f of xy equal to xy upon x square plus y square if xy is non-zero, and 0 if xy is 0. Find fx at 0, 0, fy at 0, 0, and also prove that f is not continuous at 0. That means this example says that the partial derivatives are exist at the point 0, 0. So let us calculate first the partial derivative of f with respect to x at point 0, 0. So at the definition, if I apply, this is 0 plus delta x comma 0 minus f of 0, 0 upon delta x as delta x tends to 0. So if you apply the definition of f, it is written in this manner: xy upon x square plus y square. So it is delta x into 0 upon delta x square plus 0 minus f of 0, 0 is 0 is given to you. So it is 0 upon delta x. If you simplify this, it will gives me delta x tends to 0, 0 upon delta x. So that turns out to be 0. Next, fy at 0, 0. So that also in similar manner we can say that it is 0 comma 0 plus delta y minus f of 0, 0 upon delta y tends to 0 you have. So this will be the limit delta y tends to 0. So if you apply the same definition, it will gives you 0 upon delta y and the answer will become 0. So the partial derivatives are exist at 0, 0 and its values are 0. Now we need to prove that the function is not continuous at point 0, 0. So for that you have to check the three conditions. The first one, f of 0, 0 is exist and which is given at 0. Second one, a limit of f of xy at xy tends to 0, 0 is exist. And third one, this limit of xy will become f of 0, 0 as xy tends to 0, 0. See, any of these three conditions is not satisfies, then we are through. So here the first condition is satisfied because f of 0, 0 is exist and it's given as a 0 value. Let us check the second condition whether the limit is exist or not. So if you want to prove that the limit does not exist, then, and you can just see the power of the function. The power of the function here, it is xy. So here it is 1 power, x has 1 power, y is also 1 power. So the numerator has 2 power and the denominator is also have the 2 power. So it is, chances are that this limit of this function is a path dependent. So I am considering xy tends to 0, 0. The function is given as xy upon x square plus y square. So I am taking path along y equal to mx. If you consider, then this will be limit x mx tends to 0, 0, and this is x into mx upon x square plus mx whole square. So that will gives me x tends to 0, because both this condition will gives you same thing, and this will gives you m x square upon x square into 1 plus m square. So this x square will get cancelled, so finally you will have m upon 1 plus m square. So that means this limit is depends on m, and hence the limit does not exist. Therefore f is not continuous at 0, 0. The next example, let us consider that f of xy will be under root of x square plus y square. If you consider, prove that fx at 0, 0 and fy at 0, 0 does not exist, and f is continuous at 0, 0. So this is the another way is there, that is fx at 0, 0 and fy at 0, 0 is not exist, but the function is continuous. So let us try to prove this statement. So what is fx at 0, 0? As per the definition of a limit, this will be the limit of f of 0 plus delta x comma 0 minus f of 0, 0 upon delta x as delta x tends to 0. So as per the definition, this is nothing but the limit of delta x tends to 0 square root of, this is delta x comma 0, so it is delta x square plus 0 minus 0, because what is f of 0, 0 you will have is under root of 0 plus 0, so that is gives you 0. So f of 0, 0 will be 0 upon delta x. So you will have limit of delta x tends to 0, a square root of delta x square you will have upon delta x. Now this square root of delta x will gives you two answer. Either this square root is plus or minus, so that's why I can write this is as limit of delta x tends to 0 mod of delta x upon delta x, and you know that this limit will gives you either plus 1 or minus 1 if you go in the left hand side and right hand side. So that will gives you limit delta x tends to 0 plus delta x upon delta x will be 1, and limit of delta x tends to 0 minus delta x upon delta x will be minus 1. So that's why the limit of this is does not exist. So that means we can say that fx at 0, 0 is not exist. Similar manner, what is fy at 0, 0? As per the definition, that is limit f of 0 comma 0 plus delta y minus f of 0, 0 upon delta y as delta y tends to 0. Now you can calculate what is limit of delta y tends to 0. This is square root of 0 plus delta y square minus 0 upon delta y. So again in the similar manner, delta y tends to 0 will be mod of delta y upon delta y. This has plus or minus answer, so that means limit is not unique. So hence we can say that fy at 0, 0 is not exist. Now in the second argument we need to prove that this function is continuous. So to prove that fx y equal to square root of x square plus y square is continuous, it is sufficient to prove that for every given epsilon greater than 0 there exists a delta greater than 0 such that we have to check the continuity at the point 0, 0. So that's why it is mod of x minus 0 less than delta y minus 0 less than delta implies mod of f of xy minus f of 0, 0 less than epsilon. That we need to prove. So what is you have is mod of x is less than delta, mod of y is less than delta. So that gives you x square is less than delta square, y square will be the less than delta square. This will implies x square plus y square is less than 2 delta square. So the square root of x square plus y square is less than square root of 2 delta. And what is this side? We have to prove that this will be less than epsilon. So what is f of x y minus f of 0, 0 that is square root of x square plus y square minus f of 0 is 0, 0, 0 is already 0, and this is already less than square root of 2 delta. If you want this is less than epsilon, so what is your delta you need to choose is delta will be less than epsilon by square root of 2. So you can have for every epsilon greater than 0 there exists a delta which is less than epsilon by 2 which is greater than 0 such that mode of x minus less than delta mode of y minus less than delta implies that f of xy minus f of 0 0 is less than epsilon. So hence we can say that f is continuous at point 0. So this example shows you that if f is continuous, it does not imply that its partial derivatives are exist. Let's have the next example. Consider this example f of xy equal to x cube y cube upon x minus y, as xy is not equal to 0 0 and 0 as xy equal to 0 0. Check f is continuous or not. Also check that fx at 0 0 and fy at 0 0 exists or not. So you have to check two things. First one is whether this function is continuous or not. The another one is whether the partial derivative at 0 0 there are exist or not. So first, if you want to check whether this function is continuous, you have to satisfying three conditions are there. The first one is f of 0 0 is already 0 given to you, so there is no problem in that situation. The second one that we have, that is limit of xy tends to 0 0, f of xy should exist, but if you choose the path y equal to x minus mx cube, then what is this limit will turns out to be x comma x minus mx cube tends to 0 0. The function is x cube plus y cube is this x minus mx cube whole cube upon x minus mx cube. You just see that this x is cancelled out, so we'll have it is limit of x tends to 0 x cube plus x minus mx cube whole cube upon mx cube, because this is x will cancel out and minus minus become plus, and the numerator you will have x cube common, so that's why it is limit x tends to 0 1 plus 1 minus m x square cube upon m, so that will leads to 2 by m, which is depends on m. Hence we can say that f is not continuous at 0 0 because the limit is not exist. Now the second question was to check whether the fx at 0 0 is exist or not. So let us see the fx at 0 0, that is limit f of x, that is 0 plus delta x comma 0 minus f of 0 0 upon delta x, as delta x is tends to 0, that is limit f of delta x comma 0, as per the definition it is x cube minus y cube upon x minus y. This is the x cube plus y cube upon x minus y, that was the definition. So if you use that one, this is delta x cube minus 0 cube upon delta x minus 0 minus f of 0 is given as 0 upon delta x tends to 0. So if you simplify, that is limit delta x tends to 0, the numerator will have delta x cube upon the denominator this delta x and this delta x together, that is delta x square. So we will have finally delta x, as delta x tends to 0 will have the answer 0. So the first order partial derivatives is exist at point 0 0. Similarly fy at 0 0, if you calculate, that is limit delta y tends to 0 f of 0 comma 0 plus delta y minus f of 0 0 upon delta y is there. So as per the definition, you will have 0 cube plus delta y power 0 upon 0 minus delta y minus 0 because f of 0 0 is 0 upon delta y. So finally you will have limit of minus delta y cube upon delta y square you will have, as delta y tends to 0. So that is gives you 0 answer. So means that the partial derivative of the function is exist, but function is not continuous. So this examples shows that the existence of both partial derivative at the point need not imply the continuity of the function at that point. And the reason being the partial derivative is only exhibit because the rate of change of f of xy along only two paths we have, namely the ones parallel to axis. More general concept of rate of convergence of a function, which takes into the account on all the directions, is described as a gradient of a function. So that concept we'll learn in my coming video. We'll learn that. Till then, I'm stopping here. Thank you very much. Bye bye. If you like this video, please press the like button. If you have any comment, suggestions or a question, please drop down in a comment box below. See you in next video. Bye bye. Sayonara.